Hello, my call sign is N3VCA, and I am working on my amateur radio station, and I needed a distribution for my power poles into my different pieces of gear. This particular unit here is a Windcamp AP 8-port 40 amp distro unit. I decided to do an unboxing today because I haven't seen any videos online. So I thought I would open it up for you guys and we can see what it's made of. What do we have here? We have a QSL card. Very nice. We have spare fuses, a fuse puller. Looks like some Velcro. Looks like the heavy duty Velcro. And we have a whole bunch of power pole connectors. Trying to read what it says on the connector, but we have a bunch of these. And the actual unit itself is, look, we got some more stuff. Some of the rubber boots for your cables to go into, and the servo to come out, the power pole to come out. And we actually have the unit here. Let's open it up for you guys. Nice die-cast aluminum chassis where the two halves meet together, and two end caps that hold the two extruded channels together. There's a couple different manufacturers of these distro units. You can get them on eBay. You can get them on Amazon, or you can go to an amateur radio site and you can find different models depending on what your preference is. I chose this model because the end caps are screwed on. I am going to make a modification to these end caps, or replace these end caps, so I can make a... Okay, we're going to start by removing all our fuses here with the supplied fuse puller. One of my issues I have with these advertised 40 amp power distros is that the actual 45 amp connector only takes 10 gauge wire, and as you know, 10 gauge wire only supports up to 30 amps, so it could be a bit misleading if you expect it to pull all 40 amps without using a larger connector that's rated for at least 8 gauge wire. So nearly, these pretty tight in here. I could use my fingers, but they gave me this to use. I'm just using a small, very small hex head screw. Don't want to lose these screws. Okay, so, oops, there goes my end cap, but that's okay. Pop this off, and here's my circuit board. Give you a look at this. I don't know if the camera can focus, but it's pretty straightforward. You're just fusing the positive side of the rail. The negative side is just a straight through, so there is no fuses on the negative rail. And let's see if we can slide this out. Okay, and if we turn it over, you can see they used a generous amount of solder, and looks like the negative rail does have a small bus bar going through it. I would say that's maybe an 18 gauge wire that's here, but everything else looks to be clean. And also there's a bus wire on the input side of the sorry about that, bus bar on the input side right here. If we wanted to, we could beef that up a little bit, and I may do so, but that's pretty much the internals of the Windcamp. Here's a close-up of the board. It does say it does have 2 ounces of copper. Here's some of the inputs, or I'm sorry, outputs, just to show you the quality close up. And there is no lights for a fuse outage or a power indicator. I may add a power on indicator if I can find an LED in my jump box. The supplied power poles that they give you are not actually power poles. The brand is, if I can read this, ANEN, and they look to be pretty close to what the originals are. But I may or may not use these, and we'll see how that goes. The plan is to fabricate new end caps with this aluminum angle that I have, so that I can run basically a piano wire through the locking pin of the connector all the way across through both ends. Rigrunner does have a kit for this. It's about $13 or $14, but I'm going to fabricate my own. Here's a close-up of the bus wire on the negative rail here. For size comparison, here is a 12 gauge wire. So what I'm going to be doing is adding this onto the positive and the negative rails to help with the current. Here's our 12 gauge wire, and what I found out that this does not fit in between the printed circuit board and the chassis. So what I'm going to do is I'm going to have to flatten it somewhat with a hammer, and then I'll have clearance for this wire. Now that I've tinned my copper, I'm ready to add it to the circuit board. As you can see here, I've already done the negative rail in addition to the standard one. So that's my negative right there, and I have the negative done. Now the positive is going to go in between these here all the way down, because that positive is connecting these 2 legs here. So what I'm going to do is just flip it over, and we're going to solder it all the way down. Of course, we want this as flat to the circuit board as possible. So I'm going to be using my clamps here, my vice grips, to get it down flat to the board. I need to adjust it some. Don't want to squeeze too hard, of course. That's what I'm trying to prevent. We just want enough to, just enough to hold it on. There we go. Actually, and then let's try to get this done. I'm trying to do this. And there we go. Got that one done. Using the vice grips so I don't burn my fingerprints off. There's the last one. Okay. Whoops. And there we go. Like I said, I'm going to have to check this. As a precaution, I did put about 3 layers or 1 layer of electrical tape to the bottom of the chassis, so when I slide it in, if I can get this in right, when I slide it in, I'm meeting some resistance. When I slide it in, we're not grounding our rails together, so I'm just going to have to touch this up because I got a few high spots here. So here's our completed bus bar soldered. I did check for continuity on the negative rail and the positive between the terminals of each spade connector, so we're all good there. And when we're done, there may be a couple high spots in terms of solder. You can either hit your iron on them, or you can just use a light knife and scrape some of those off. And trying to get this back together. Should slide. It has to go back in the channels. Am I in? No. So we're just sliding it in, and I'm meeting a little bit resistance, but it's still going smooth. And like I said, the electrical tape on the bottom will help prevent any mishaps. I will check it again for continuity and shorts. Here's the amount of space that we have in between the circuit board and the bottom of the chassis. You can notice there that's my bus bar is right there, and the negative one you can't really see at the moment. But that's not a lot of space, so that's why I put the electrical tape down the bottom to prevent shorts in between the positive and the negative bus bars. The next thing I wanted to do to my power distro is add an LED power indicator. This red LED came out of one of my kids' remote control fire trucks, so the value isn't known, but I'm guessing it's going to run about 15 to 20 milliamps. The resistor that I'm going for is a 1K resistor. It doesn't necessarily need to be bright, it just needs to be shown that there's power. And the modification that I'm doing to my board, which is right here, I did notch out, put a notch in the board so I can run one lead to the negative here underneath the board, and the other lead is going to run to this side. If I run it to the opposite side, even though the fuse blows, it's still going to show power on the LED. If I wired on this side, if the fuse goes out, the LED will also go out. Here it is all wired up. We have our main power in, and the positive goes to the fuse to the rest of the bus bar, and our resistor that we added into the LED. And on the back side, we have that wired onto the negative bus bar. But I am going to have to add some hot glue. Okay, I got everything hot glued down. I got the wire in that notch and under the resistor and LED. I did add some electrical tape to prevent this lead from possibly touching the positive terminal here. But I think there's enough hot glue underneath these two to prevent that. But just in case, I added it anyway. Now all we do is drill the top of the chassis for the LED. Okay, here's the top of the chassis that I drilled out. I started off with a 1/16 and worked my way up to 5/32, which is just under 4 millimeters. So the LED doesn't protrude through the top of the chassis. I also cut a small relief in the back of the chassis for the LED to sit in. The two halves of the chassis go together fairly well. Just requires a little fiddling. And there we go. You notice the LED doesn't protrude from the top of the chassis. It just merely just sits flush in there. The next part is most difficult. I will make new end plates out of this aluminum angle. Using the original as a template, I will add an extra hole up top for a locking pin that will go through all the connected devices. Here's our end plate with the 4 holes drilled. I did drill 2 additional for mounting onto a solid surface. Now our next step is to make a point or a hole on this end plate for our locking bar. In order to do that, I am going to use this 5/64 inch piano wire, which I have made into a point at one end to be used as a scribe. So once we have our end plate on, we put 2 or 3 connectors, and we're going to use that as a guide for our scribe so we can know where to drill into our end plate. We're just going to push and turn it to make a small point on our aluminum, as you can see here. Here you can see the mark we made with our point. That's where we're going to drill for our locking bar. We're also going to round some of the edges off for safety and aesthetics. Okay, here's a nearly finished product. As you can see, the locking bar goes through the ends. I have the ends cut and the 4 screws mounted on each side. The locking bar is just a piano wire that I drilled to go through both ends and the center of the connectors. And it just pulls out simply like this. So if you have it a horizontal or vertical configuration, this will work for you. One thing you do notice is the lack of a main fuse. Like I was mentioning earlier, that these connectors, I have it locked in, these connectors at most are good for 10 gauge wire, which is 30 amps. So what I'm going to do, instead of using the stock 40 amp fuse here, I'm going to replace it with a little fuse. It's a 30 amp universal circuit breaker. The part number is UCB30BP, and basically this is going to replace our main circuit breaker for the distro. And this is I'll show you here. This is a SAE J553C Type 2. What that means is that this is resettable, and when it blows, you have to disconnect the power that's going into the distro to reset the fuse. Here's a close-up of the circuit breaker. As you can see, there's score marks on the legs, so you can break off as much as you need or as little. In my particular application, I'm just going to remove one from each side. And one thing to note about this particular unit, that the legs are all center of its body, but on my distro, I have enough room to accommodate that. Here is our circuit breaker. I did put double layers of heat shrink in case it contacts the chassis. These are available at auto parts store. I got this one for $3.59, not including tax. But I've seen them as high as $4.99. And for those who are wondering, these contacts don't have any continuity with the case. Here's the final completed power pole distro. I'm currently using alligator clips to power it, as I haven't had time to crimp any connectors. And in the stock form, I think it's okay. As you know, my feelings about the 10 gauge wire, it's limited to 30 amps. So I would consider this a 30 amp unit, unless somebody can tell me otherwise. That and the Busbar, I guess it would be sufficient if when combined with the printed circuit board. But I think it's more robust now, and I'm very pleased with the modifications that I made to the unit. If you have any questions or comments, put them below. And if you like it, share it. So I want to say 73s. This is N3VCA.